Okay, roughly sketch the graph of x to the 4 minus x squared. Now this one's an interesting one. It's the same kind of deal as the previous example, but it's degree 4. Now first of all, it's x to the 4 here. That's a positive x to the 4. It's not negative, so it's going to be kind of a U shape like a parabola. But the generic shape for a degree 4 guy would be this, something like this. Right, it doesn't need to be symmetric, but that's roughly the shape. It kind of goes down, has a wobble, and it can turns up. So, if this is happening, let's think to ourselves some interesting stuff. If, for example, I knew where I crossed the x-axis, then that would be pretty useful guiding information, right? Because it would tell me kind of how things look roughly. So again, this isn't completely rigorous what we're doing, but it's really good practice. So x to the 4 minus x squared is equal to, well, let's bring out an x squared, and it's, what is it, x minus 1, or x squared minus 1, sorry. Now this factors as a difference of two squares, thankfully, x squared, x minus 1, x plus 1. And we want to know the x-axis cross points, right? So, or points where it touches at least, so that corresponds to the zeros of the function. And again, by the zero product property, this happens if and only if x squared is equal to 0, or x minus 1 is equal to 0, or x plus 1 is equal to 0. You can't have the product of three numbers be 0 unless at least one of them is 0. So now, tidying this up a little bit, this is if and only if, of course, x is equal to 0, or x is equal to 1, or x is equal to minus 1. So now let's take a moment to plot these points and think, how on earth could I get something like this kind of U-ish shape work? Let me get this more properly done. So as I said, this isn't completely rigorous mathematics, but it's like very good to understand the basic behaviors of these. So what are we saying? Well, we've got 3 points where we're going to touch the axis. There, there, and there, let's say. Where this is going to be 1. This is going to be 0. Oh, what am I saying? 1. It's minus 1. And it's 1 over here. And what have I got? Well, I need it to look like this guy above. That's the generic shape, if you want, for the degree 4. So in this case, I think we've got something kind of cool happening. The only way to do this is if the following occurs. Is if you kind of come down like this. So you're going to come down. You're going to cross there. So you've got to turn now. And you've got to be careful, right? So we're going to turn around at some point and come up. So we're going to have to cross here. Whoa. I'm going to cross up here somewhere, right? So maybe I have to go up. But then what? Well, okay, this is fine. Let's keep going. Well, then I've got to turn around again and go down here. But now I've got a problem, you see. If I've done this, if I keep going, I've got to turn around and I've got to cross somewhere else. But that can't happen. I can only cross at 3 points. So where's the mistake I've made? The mistake has to be what happened at 0, basically, I think, potentially. I mean, it's not the only possible mistake, but it feels to me that's what has to have gone wrong. This one is kind of subtle, but certainly what we've done at 0 is a problem. We could look at this a second and observe that, well, that's an even function, isn't it? Right? It's an even function. That means that if I take what I've done on the negative side and I reflect it across the y-axis to the positive side, it has to be exactly the same. So there's only one option in this case. I do need to have a 0. I've got to have a 0 here, but I've got to turn around at that point and go back down. I have to be symmetric. So I have to look like this. So terribly clever, right? And I can kind of tell you intuitively why that has to happen. If you hadn't spotted, for example, that you were... So if you hadn't spotted that you were even, there is another way to do this. So you could have had a scenario where you did this. You kind of cross here, you go up and then you do this kind of touching trick over here. You could do something like that instead. But I can tell you why that's not the case algebraically. The reason it's the 0 is the one that's just touching and not crossing over, it corresponds to the fact the 0 up here is repeated, if you want. It's an x times x. The 0 factor is occurring twice. That's the reason you're getting this funny touch behavior, where crossing over like this corresponds to the fact there's just one term here. So that's why this red guy couldn't have happened anyway, because it's the 0 that's the repeated 0 of this, whereas -1 and 1 only happen once in the factorization. So this is quite difficult, right? This is fairly advanced algebra, but it's nice to kind of know the basic behaviors of these things.